All right then. Let's start the second version of this code. My bad. Well, it's 5 in the morning and my brain is not working as good. So, yeah, let's start the second part of this lecture, which is we'll be taking a look at reverse engineering. So, I think many of you were waiting for this, the whole hacking thing, hacking the code you are given, or like taking a look at the assembly and realizing what it does and finding how to change it to your own way, so you know have more power over it. So yeah, we like like any other classes, we'll be taking a look at a very simpler version of it, but you are always welcome to work on a very harder version, and the more you work on it, the better understanding you get and the more experienced you get. Like all those modding communities and all those you know there are so many video games that are modded and like cracked and all of those just by using reverse engineering. So it's a pretty cool concept, and honestly I wish I had a better expertise on it. Like I am on a beginner level, but well, I would say kind of intermediate, but like not an um, advanced user or programmer in this case. So hey, you are always free to get better at it, get better than us. Like that's the whole point, right? So yeah, we will be taking a look at this assembly code, and we will be seeing how we can turn it into a C code. Okay. So yeah, let's see. The first things first, we do some always at the beginning of the code. We do some sort of stack pushing and all of those, because we need to know where the return statement is and where the variables are going to go, and like which variables are provided to us. So this is the stack setup for this code, and the compiler, like this part is the stack setup. Like we put by doing this, we are putting the previous version, like previous address in the stack. Then we are doing this, so we are changing RBP to the new position of the stack, and then we are doing subtraction of RSP. So with 20, we know that we are going to have variables that have like this is how we get 20, right? So we are going to actually have five variables in this case, unless we have a double or something like that. So if we have if we have just integers, in this case we are going to have five variables overall. Okay. So this is how the stack setup looks like in this code, and this is going to be our return statement. Okay. So yeah, so with that we know that we need to focus on this because these are more or less the same as before. So yeah, let's take a better look at the main body of the code. So first of all, we need to do is figure out what type of variables we have. So let's see which part of the stacks we are using multiple times, so we know that those are variables. So we have this part, we used it here as well, used it here as well, and here. So this is one variable that's being used again and again. So we know that this is going to be a variable we'll be needing later. There's another one, this one. We use it here, 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 here. So we know that this is going to be another variable. Let's see if we have anything like that, like any other variables that we're going to use. So this minus 20, it's also being used repeatedly. So we can assume that this is also a variable. Let's see how it goes. So first we are going to filter out the repeated access of the stack, and we are going to name them. So we are going to name the RBP -4 into local 1. We're going to name RBP -8 into local 2. And if you so we have been using this RBP -20, right? If you look at this part, we are copying from a registered EDI and copying it to here. If you recall from the previous lecture, like not the previous video but the previous lecture, we saw that some of the, like we know that the parameters of the functions are going to be sent as registers. 6 parameters, like the first 6 parameters are going to be sent as registers, and later on they are going to be put into stack. So in this case, a parameter is sent to this code as EDI. Okay, so EDI was a parameter, and now we are putting it inside our stack, which is our BP -20. So we are going to call it param1. So right now we have 3 variables: local 1, local 2, and a parameter 1, which is also a variable, right? And another thing to notice over here, this f1. So usually these labels are based on their function name. So we are going to call our function f1. We have 1 parameter. And okay, another thing to notice here, like over here, we are doing L, right? So from that, we can assume that all of them are integers. So it's going to be an integer, and we are going to call it param1, right? We also have an integer called local1, integer called local2. So what happens to local1 and local2? Over here, we're moving 1 into local1 and moving 2 into local2. So we are basically doing this part in the assembly code, right? So yeah, and another thing we need to know is like the return statement, right? So let's see how we are going to figure it out. So if we take a look at the code again, right before the return statement over here, we are doing something like move L RBP -4, and we are putting it in EAX. If you recall the previous previous lecture, you know that EAX is our return type, return value. Okay, so whatever we are returning, it's going to be put into EAX. So in this case, we know that EAX is our local 1 because we copied it in local 1. Let's see where we did that. So yeah, we are putting our local 1 into EAX, right? So our return statement is going to be local 1, which is integer. So it's going to be integer, and we're returning local 1, basically this and this. Okay, then we are going to take a look at in the the conditions, like how they are working. So there are 2 jump statements, a comparison statement, and 2 labels, all of which indicate the presence of a loop. So usually you can assume that it's a loop if there are like 2 conditions, like sorry, 2 labels. But the best way to know there's a loop is you take a look at the jump statements and see if they go back. So in this case, it goes back to L3, right? So basically this is going to be a loop. Like from this, you can pretty much guess that this is going to be a loop because it goes back. Instead of going down to the next statement, it's going to go back up. So this part is definitely going to have a loop. Okay, so if you remember the while statement we worked with just a while ago. Yeah, I shouldn't do that anyway. Yes, the while statement. So let's see what's happening here. So we are doing a move RBP, so this is local 2, and we are putting it into EAX. Then we are doing a comparison against RBP. So this is basically local 2 minus, this one was param 1, right? And then we are checking whether they are less than equal. So we are basically checking something like local 2 less than equal param 1 as stated over here. So if that's true, the loop repeats. So from this we can actually figure out what our condition is for the while loop is going to be. So this is how far we have come. We know that our function returns an integer. It's called f. It's going to have one parameter. We are putting some value in it. We have a while statement where it checks whether local 2 is less than param 1, right? And we also know that the return statement is local 1. So this is how we have come, like how far we have come. Now let's see the rest of the part. So this is the body of your while loop. So what's happening here is pretty straightforward. We are putting something into EAX. The something is our local 1. So EAX is going to hold on to the local 1. Then we are doing a multiplication with EAX and local 2. So this is what happens. Then we are taking the answer of it and putting it into local 1. And then we are doing a addition to local 2. So local 2 is going to be incremented. So from this we have the body of the while loop, which is pretty much this. It is pretty straightforward, and with that we actually covered the whole assembly code. So this is what the assembly code looks like in C. So what do you think it's actually computing? Like, you have any answers? Well, I'll let you figure that out. It's pretty a very simple C code, and we saw that how we can get that from an assembly, right? Okay, so remember you use 0, so this means it has the least amount of optimization. So by stating that instead of 0 it's going to be 1, it's going to be more optimized. Okay, so let's see what difference it makes over here. So the setup the stack setup code has been omitted. There are only a few locals and one parameter, so we don't need the stack. So yeah, as there's so less variables we're working with, and so less parameters we have, like literally 3, we can just use our registers and we don't have to worry about the whole stack in the first place. So we are completely ignoring the whole stack setup. In the return statement there is no cleaning the stack, right? So the stack clean code is also mostly gone. Only the return instruction remains. We'll take a look at it later. Okay, so this is what is happening. EDI is holding on to param 1, EAX is holding on to local 1, EDX is holding on to local 2. Okay, the comparison is same as before. This is the body of the while loop, was it? Oh no, this is the normal one, the first initialization. So this was x and y, I think. Oh, sorry, local 2, local 1. As you can see over here, we are just using the registers directly instead of using stack, because we're optimized code, right? We are doing multiplication directly, we are adding directly, we are doing a comparison. If it's greater than, then it goes back up. So as you can see, the while loop also kind of shrinked because it doesn't have the whole back and forth with the whole stack and registers thing, right? So yeah, over here we have been like working on this directly. So as we are not using the stack at all, it decrease the length of the code a lot. Okay, so another thing you can try is like if you still want to see what happens, you can, instead of io1, you can try io2, sorry, o2 or o3, and see how much the code changes. But this is basically the whole, reverse engineering. So you have a assembly code and you actually changed it into a C code, which is pretty interesting. I think it's a pretty interesting concept. And you will be working with your binary bomb soon enough. And the thing is, like, if you understood this lecture, binary bomb is going to be very trivial. You just take a look at the code of your binary bomb, you just reverse engineer it and um, turn it into a C code. And then you just like take a look at your C code and be like, okay, this is where the bomb is going to blast, and so I'm just going to ignore that part and get the exact value or right value. So this lecture is basically the whole walkthrough of how you're going to work with your binary bomb, and I hope this made sense. If you have any questions, come to my office hour where literally nobody shows up. So yeah, I'm free to answer any sorts of answer you are seeking, like any sort of answer to your questions. I may not be able to answer everything because assembly is a very hard concept. Um, but I'll try my best. Okay, so I hope this made sense to you. This lecture was helpful for you, and yeah, I'll see you next time.